And thank you, Dave, for inviting me and for insisting on this invitation. So I hope that indeed there is something meaningful in what I can say today. I have to disappoint Paul because I will not talk about modeling heat pumps into a 2050 vision.
That's Chris's presentation.
And yeah. And maybe also I have to disappoint you further because I'm a big fan of the European Commission voting for and deciding for renewables being used by heat pumps, which is actually, as a general statement, not the European Commission that did that, but all the member states agreed. So somebody in the UK said yes to that. And I think it was a very smart, decision in the first place. But how I wanted to start this, when I was about 14 years old, we had an insurance company that started with pictures like this. They made visions of the future, and these visions always looked very great. You had self-driving cars, you could just play chess or sleep while driving. Everything was renewable based, and so heating and cooling was no issue. And after Paris and after the COP21, I think it is becoming an issue because we discuss renewable energy also in Brussels, and I'm a lobbyist. That's my main task, talk to the policymakers on what needs to be done. We talk about renewables and we talk about electricity. And this is the one of the graphs, one of the many graphs. If you want to dig into it, it's really probably a lifetime endeavor. How the energy system could develop in the future with relation to the CO2 emissions that come out of it. And this is all the possible ways that have been calculated by UNFCCC, by Joris Rogelje and others. And they have tried to come up with some likely pathways until 2050. And these likely pathways, they show us that there is actually a need to go beyond zero emissions. And that's something I am missing a little bit. You hear a lot that people say, yes, okay, now we have to do something. But it also has to be cost efficient. What you don't hear is what's the alternative costs if we don't do this. And right now there's the Hurricane Matthew going over Florida. Maybe it's not subject to global warming, but maybe it is. And then the cost is quite tremendous. I've also heard that in Denmark, they do all the construction to take care of overflooding in the city. I don't know what would happen to London if the sea level rises, but you can understand the issue. So there is a great understanding now from the policymakers to say, yes, we need to decarbonize the energy system. And this is the energy system of Europe. So this is what we see in 2012. That's the best data I could find for this. And it shows that heating and cooling actually has more than 50% of this energy system. And it also shows that space heating, residential space heating, is another 50% of that. It also shows that industrial applications have another around 15% of the total. This is always on the total application. And now we know that heat pumps, and I will not talk about that at all, heat pumps can provide heating and cooling in a very efficient manner. I think the current developments that we see in the reality, and I will see more in Chiventa, where I'm going tomorrow morning, will prove that efficiencies is increasing and application areas are increasing. But this is what we need to decarbonize. So if we don't decarbonize the heating sector, we will not decarbonize the heating system. That's I'm quite convinced of. And maybe a major reminder, because that's what I hear when I talk to policymakers. They say, yeah, it's all well and good, but it cannot cost much, and we should still use gas and oil for the foreseeable future. But if you burn fossil fuels, you will emit CO2. So it's rubbish in, rubbish out, in principle. How efficient that is, that may depend, but of course in the end it has to be zero, as I showed in the second slide. And now I looked at some numbers from Europe, and this is the CO2 emission curve for Europe as it stands, 2015, the green line, and this is if you take a very simple linear extrapolation, what we have to do to achieve an 80% decarbonization or a 95% decarbonization, that's the green line, until 2050. And this is the heating sector, residential, mind you, because I don't have enough data for the industrial applications. But this is the residential heating sector, and if we don't decarbonize it until here, then it means that if it stays here, that all the emissions that are still available in 2050 will be eaten by the heating sector. And I doubt that this is acceptable by other industries and by transport. So it's one conclusion that we can say: we have to decarbonize the heating sector. We have to do much more than just decarbonizing it by 15 to 20%, which is sometimes proposed these days by protagonists of the gas condensing boiler fraction. Because this is what you get. If you go here to the dotted line, that's the 15 to 20% that you can get in improvements from replacing existing boilers with gas condensing boilers. There is a number of studies of people much smarter than me, and one of them is from the Fraunhofer Institute, and they have shown that until 2030 we have to invest both in heating technology and in insulation to achieve a meaningful decarbonization for the whole system, because we're always talking systems of around somewhere 60 to 80%. And obviously in 2050 then, because that's the long term, we have to go to zero. This is again my simple mathematics. If we take linear emission reduction and we want to go to zero, then it's every 7 years another 20 percentage points. And if we then look at the opportunities that we have, so what could we do if we want to decarbonize? And that's then my answer to where do heat pumps fit into the 2050 energy system. Then we can take the 100% value from here. So this is my 100%. And we have this in mind. And then we say, okay, if this is 100% in 2015, after 7 years we have to be at 80%, after 7 years we have to be at 60%, after 7 years, you understand the story. So it means also, what do we use still? We use a lot of coal, we still use direct electric in many countries, and of course the protagonists of that, they say no problem because we decarbonize the electricity system. Then there's people that say, yes, oil is the cheapest solution, so we cannot take it out because people have to be able to afford energy. But again, you see immediately that all these three don't work with what we need to do. District heating is a difficult one. I really could not get very good data on the emission factor of district heating. You ask 5 people, you get 7 results. I'm serious. If you look at how much positive support district heating gets, the lack of data is quite astonishing. And I say that because heat pumps have been punished for lack of data since I can think. So actually there has been a lot of development. I don't see the same in district heating. I'm not saying it's bad, because district heating in the end is, as many people pointed out, a distribution technology and not by itself good or bad. But we should have better data. Then if we look at gas, yes, that's good. It's 242 grams of CO2 per kilowatt hour, and that probably is not going to change. Then we look at heat pumps, and again, you can make a lot of discussion. I just use a simple efficiency of roughly 3, and then you take the average emission factor for electricity, and then you end up around here. And there is a huge discussion in Europe on the primary energy factor. We can discuss that over lunch, but it would actually blow out the whole agenda here. And then, of course, there's biomass, and biomass is, if you ask this or that person, a very good technology, or it's also polluting, and we have a lack of resources and so on and so forth. So I guess we can agree at least that we will not have enough biomass to fulfill 100% of the European energy demand. So it will be a mix of these that are below the grid. And then I can say heat pumps fit quite well, because at least at the current average efficiency of the electricity grid, we fulfill already a 60% requirement, which we have to achieve in 2029. Which also leaves us quite some time to develop the technology further, to improve efficiency, and to develop business models that allow for a proper integration of demand response, which heat pumps do very well. Just to show three pictures, because heat pumps can be used in residential, commercial, and industrial applications, but that's just a reminder, as I assume most of you know that anyhow. And how would that look in the end? Again, another group of scientists from Aalborg universities have come up with this model, and I think that's important that we start to develop models of how this energy system in 2050 should look like. Because at the moment we discuss bits and pieces here and there, a little bit of this, and everybody claims they can do all, but obviously they can't. And if we look at the vectors for mobility, heating and cooling and electricity, and then you can see that heat pumps certainly are at the center of this. How do we get there? And that's the other important thing. We need a transition period. We have to explain to people that this is a tremendous change. It applies to R&D, it applies to manufacturing, it applies to the installer, which is probably the biggest elephant in the room, and it applies to maintenance, but also at business models. And I just, to use these, the same term, I think we need to redesign, we need to retool, and importantly, we need to reskill our value chain around heat pumps within the next 35 years. And if we manage to do that, then in my 2050 vision, heat pumps fit everywhere. Thank you.
Thanks, Tom.
might